Hello everyone, welcome to the digital electronics class. In this presentation, we will understand what is a D flip-flop and how we will make a D flip-flop by using a SR flip-flop. We already know what is a SR flip-flop. So, we have drawn the truth table of the SR flip-flop as shown in this table, and from the truth table of the SR flip-flop we will derive the conclusion for the flip-flop. On observing the truth table of the SR flip-flop, we see that if we want to store a 0, then we will have to give the inputs as S is equal to 0 and R is equal to 1. And if we want to store a 1, then we will have to give S is equal to 1 and R is equal to 0 as the input. That is, if S is equal to 0 and R is equal to 1, then a 0 will be stored in the SR flip-flop, and if S is equal to 1 and R is equal to 0, then a 1 will be stored in our SR flip-flop. Also, on observing this table, we see that the inputs S and R are always complement to each other. That is, when S is equal to 0, R is 1, and when S is 1, then R is 0. So, there is no need to give this S and R inputs individually. We can just give one input to this flip-flop and complement the other. That is what we have to do to get the D flip-flop. Now, we also see from this truth table that when the value of S is 1 and R is 1, then this is an invalid case. So, we are not going to use this case. So, if we want to store our data, then in that case we can do so by using a D flip-flop, which is shown in this figure. Here D is the data, and this is one of the most commonly used flip-flop, because in D flip-flop we just give the inputs, we store the data, and then we remove the clock and our data will be there. So, D flip-flop is a very important flip-flop. Now, we see that we can convert a SR flip-flop to D flip-flop by connecting an inverter from S to the R input. So, if D is 0, it means that S will be equal to 0 and R will be equal to 1. And if the value of D is 1, in that case S will be equal to 1 and R will be equal to 0. So, we find that we need only a single input, that is D, and to get the other input we just complement it. This is what we are doing here to obtain a D flip-flop by using SR flip-flop. So, we can make a D flip-flop like this. This is how we make a D flip-flop. Now, this entire circuit is contained in this box, and this is the symbol of D flip-flop. Now, let us find out the truth table for D flip-flop. As we see from here that this is a very simple truth table. Here we will have a single input D and a clock as the input of the D flip-flop and Qn plus 1 as the output. Now, if the value of clock is 0, that is clock is low, it means that this circuit will not take any input and the output will be the same as the previous input. So, Qn is the output in this case. Now, when the clock is high and the value of D is low, then it means that if D is low, it means that S is 0 and R is 1 for this particular case. So in this case we find that the value of Qn is 0. So the value of Qn plus 1 will be equal to 0 in this case. Now if the clock is high and the value of D is 1, it means that S will be equal to 1 and R will be equal to 0, and in this case we find that the value of Qn is 1. So the value of Qn plus 1 will be 1, as we see from the truth table of SR flip flop. Now the fourth case, that is when S is equal to 1 and R is equal to 1, this is not possible in this D flip flop because we have connected an inverter from the S input to the R input. So we cannot get this configuration in the D flip flop. So this is the truth table of D flip flop, and as we can see from this truth table, this is a very simple truth table. So this is how a D flip flop works, and that is all regarding D flip flop. Hope this topic is clear to all of you. See you again in the next presentation.